Welcome to this lesson where we are going to look at sets, to be specific, Venn diagrams. The type of Venn diagrams we're going to take a look at in this is the ones that come in paper 1 that involves shading and set notation. So I'll start with set notation because there is an important way of representing sets that has started appearing in exam questions that wasn't appearing in years 2019 and before. Okay, so there's this notation that they use. They can say set A is equal to X is such that X is a member of maybe they can X is such that X is a member of, maybe they can say prime numbers. Okay, and let me just do it like this. So they can say set A X, that's how to read it. X, this one is such that. So X is such that X, this one is member of. We learned this in the previous lesson. So X is such that X is a member of prime numbers. Of course, they'll write the full word prime numbers. In grade 9, they could just write a symbol like Z. Another symbol that was being used was, is it P? Okay. Yeah, but X is such that X is a member of prime numbers and X is less than 8. So when they bring such a set, they can even ask you a question, list set A. So to list set A is to write the actual members in set A. Okay, so X is such that X is a prime number and X is less than A. So you have to identify prime numbers which are smaller than 8. So we are talking about 2, we're talking about 3, we're talking about 5. Okay, so this is set A. Okay, so I thought of mentioning this because it has started appearing in exams in the new syllabus, so to speak. Okay, another notation. Let me give another example. So example has set E, which is X is such that X is a natural number. I'll use n to represent natural number, and X is less than or equal to 10. Okay, then there's set A, which is X is such that X is a odd number. I'll use odd to represent odd number, though that's not the right symbol to use. And X is less than 5. Then we have set B, which is X is such that X is a prime number and X is less than 8. Okay, so I'll put equal to here. So before you can solve this, for you to solve this, you need to list these sets. That's when you will find it easy to solve. Okay, so set E, what is set E? X is a natural number. What is a natural number? Natural numbers are counting numbers. Numbers we use when counting. Okay, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, just like that. So 1, in this case, they have said X is less or equal to 10. When they have put equal to, it means this number should be included if it is also a natural number. This number should be included if it is also a natural number. In this case, 10 is a natural number since we use it for counting. If you want to know more about counting, about types of numbers, you can find a link in the description to the video that discusses types of numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is set E. Then set A is X is such that X is a member of odd numbers and X is less than 5. So we have to list odd numbers less than 5. So the first odd number is 1. The second odd number is an odd number is a number that 2 cannot go into without a remainder. Does that make sense? Okay, let me say it again. An odd number is a number that is not divisible by 2. That is, if you divide it by 2, it will give you a remainder. Yes. Okay. If you divide it by 2, it will give you a remainder. So 2 is not an odd number because 2 divided by 2, it's 1, remainder 0. So the next odd number is 3. The next is 5. But 5, you won't include it because here it says X is less than 5, meaning that the numbers that are listed are those smaller than 5. If there was this symbol on the bottom equal to, you could have included 5. Okay, you could have included 5 because it says is less or equal to 5, which means 5 is inclusive. But in this case, 5 is not inclusive. So A is just 1 and 3. Okay, so this is A. Then B, X is such that X is a prime number and X is less than 8. Prime numbers are those numbers which have two numbers that go into them without a remainder. That is 1 and itself. So the first of such numbers is 2 because the only two numbers that go into 1 is 1 and 2. Okay. The second is 3. Okay. The third is 5. Okay. The next is 7. Okay. After 7, okay, so 2, 3, 5, 7 are what makes B. Okay, so once you have these three sets, you can answer question that they can ask. They can ask find a complement, which are just members that are in the universal set but are not here. Meaning 2. Okay, 2 is not in A. 4, 5, 6, 7, 8, 9, 10. They can ask A intersect B. You look for members that are found in both A and B. In this case, it's just 3. 3 is the one that is found in both A and B. Enough with set notations of this nature. We go to Venn diagrams for paper 1. So we're going to start with a concept called shading. Okay, sometimes they'll ask you to shade. Okay, so you have to know some common types of sets. Okay, and how they are shaded or how you shade them. So if we have three sets, A, B, and C. Okay, A, B, and C. If they say shade A, they just want you to shade A, which is this. This is A. Okay, so you just have to shade A without being worried about B and C. Okay. If they say shade A complement, they want you to shade everything outside A. So they are talking about this. Okay. So this is A complement, everything outside the A. Okay. So this is A complement. Okay. So these are simple. So if it B, C is the same. But what if they ask you to shade A union B? So union means putting together or joining. So they are saying shade A and shade B. Okay, shade A and shade B. Okay, that's what they're saying. So we're talking about shading A and also shading B. Okay, like this. So this is A union B. Then if they say A union B union C, they are saying shade A, shade B, shade C. Okay, so we're talking about this. Okay, so this is A union B union C. Okay, what if they say A union B union C complement? A union B union C complement. They want everything outside the A union B union C. We know what A union B union C is. It's the three sets. So complement, they mean outside, like this. Like this. Like this. Outside the three sets. So this is A union B union C complement. So complement means outside the three sets. Okay, enough with union and complement. Okay, so meaning that even A union B complement is just shading A, and it's just knowing what A union B is, then you shade everything outside the two sets. What about intersect? How do we shade intersect? So intersect is a common region shared by two sets. If they say A intersect B, they want you to identify the region shared by A and B, which is, in this case here, this is the part shared by A and B. Okay? It may seem simple when you know the sets, but when you don't know the sets, sometimes it can be complicated. So if you're not sure about what A is and what B is, here's the method that I recommend. First, shade A. So shade A, you shade maybe with lines that go from left to right like this. Okay. After that, shade B. B, use other different types of lines. You do this on a rough paper like this. Okay. So the answer is where there are two types of lines, because the lines that go left right are for A, and the ones that go bottom top are for B. So where you have done, where there are two types of lines, that's where your answer is here. Okay. So once you identify your answer, you go on the answer sheet. Now you shade on the answer sheet. Okay. In this case, if it's like this, you shade here. Okay, because here that's where the two types of lines are, the ones that go left right and the ones that go bottom top. Okay, so that's the technique that works for intersect. Let's try to make our lives a bit complicated. What about A intersect B complement? How do you shade A intersect B complement? So for beginners, I can say first shade A, then shade B complement like this. So A is this, right? B complement is everything outside B. Okay, so you avoid B at all costs. We're avoiding B, not A. Okay, so this is A, this is B complement. I mean, the blue is B complement, the red is A. Of course, you don't have these colors, so you can do lines that go left right for red and the ones that go bottom top for blue. Okay, so intersect is the common region shared by these two. In this case, you can see that where there are both types of lines, it's here, 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 here. Okay, so the final answer you can draw in your answer sheet. Okay, let me just put it here on a bigger diagram. Okay, so the final answer is going to be this. So that's how to deal with intersect. You have to do it on a rough paper, then the final answer you write it on the final paper. Okay, this is one method that I learned. Maybe you can also learn your own method. Now for advanced learners, or the shorter way is to, this works only if you have intersect and complement. Okay, so A intersect B complement, what it means is A minus B. Okay, so intersect and complement, they make minus, and this set which is between intersect and complement is the one you write here. So it simply means in A, shade everything in A apart from the part that is also in B. So we can shade everything in A, but we don't include the part that is in B. Okay, so this is the shortcut for those who may like it, but of course the easier one is that, anyway, you can choose which one is easier. Okay, so intersect B complement, intersect and complement make minus, whatever is between them becomes a set to subtract from the other set. Let's do a complicated one. A union B intersect C complement. Okay, so A union B intersects C complement. Using method 1, we have to shade A union B, which is this. So this is A union B. Then intersect C complement. We put it together with everything that is not in C. So of course we can do this. We can shade this is C complement, everything that is outside C. Okay, so this is everything outside C, and you can see the intersect region, it's here. Okay, that's why we have two types of lines. Okay, so this is what you have to go and draw on your answer sheet. Okay, then for the advanced learners, or should I say method 2, for method 2 we know intersect and complement make minus. So A union B intersect C complement, it simply means A union B in brackets minus C. So we shade everything in A union B apart from the part that is in C. So we can do that like this. Everything in A union B apart from the part that is in C. So this is A union B intersect C complement. Okay, let's try to make another complicated one. What about if we say A intersect B intersect C complement? How is it going to be? Okay, A intersect B intersect C complement. Okay, so this is our Venn diagram. Always don't forget to put E for universal set. Okay, and these are our sets. We have A, we have B, we have C. So A intersect B, we know it's this, right? This is A intersect B. So they are saying intersect C complement. What is C complement? Everything outside C. So we're talking about this. Okay, okay, this is everything outside C. Okay, so where we've done the shading twice, that's where there are two types of lines, that's where our answer is, so long as it's intersect. So we're talking about this part here. Okay, this part here. Okay, so that's our A intersect B intersect C complement. Okay, so meaning that I mean, if we use method 2, we know how simple method 2 is. So method 2 says if we have such a case, A intersect B, intersect becomes minus C. Okay, intersect and complement becomes minus C, meaning that we shade everything in A intersect B apart from the part that is in C, since we're removing C from A intersect B. Okay, so meaning that this part I had forgotten to remove the lines, meaning that this is A intersect B, so we're going to shade it, but we won't shade C, anything that is in C. So this is A intersect B intersect C complement. Okay, this seems to be quite easy. What if we have a union? What if it says the same thing, A intersect B, union C complement? How do you tackle this one? Okay, so we have A, we have B, we have C, we have universal set here, A, B, C. How do you tackle this one? So union is simple. Union, you just have to shade A intersect B and you should say complement. That's all. You can do this on the answer sheet. So A intersect B, we know it's here. Union C complement, everything outside C. So we shade using the same type of shading. It's union. We're just putting them together. Want them to be united. Okay. So this is the answer. Okay, we have done A intersect B and we have done C complement. So that's the answer. Okay, so then the other way they bring this question is they draw the diagram. They can draw, then they want you to answer. Okay, they want you to write the set notation. So if they have done something like this, A, B, C, then they have maybe they have shaded this part. What do you think this is in set notation? What do you think this is? So from our experience, we can see that C has been shaded, but the part that is in, okay, I haven't done this properly. Okay, so I want this. Okay, so okay, let me start with the simple ones. Of course, if they shade something like this, it can't come, but if they shade something like this, you can see that A and B has been shaded, so this is A union B. Okay, so this is simple. That's what they want when they draw the diagram, and they want you to come up with a set notation. Okay, so that's what they want. They just want you to write the set notation since they've already drawn it for you. It's the opposite of where they ask you to shade. Okay, what if they do this? What if they do this? Okay, let me just do this. What do you think this is? You can see that A has been shaded, but there's a part that is in B that has not been shaded. From what we have discussed, we can tell that this is intersect B complement. Why? Because A has been shaded, but the part that is in B has not been shaded, meaning that the everything that is outside B has been put as a common region with A, which is this. Okay. So for those ones who do that shading method, it's going to do it can be difficult to understand this, but for those ones who understand the idea of turning this into minus, they know that this means A minus B. Okay, so A, but everything that is in B has been has not been shaded. They have just shaded the ones everything in A. So it's A intersect B complement. Okay. Most of them you can do. If you do shading, then most of set notation you can do. Okay, so I'll just do two more to conclude this topic. Okay, or this part of the topic. So I've got A, B, and C. So what if they say they do this? They do this. What is this? So there's different ways in which you can identify it, but one thing for sure is there's A intersect B here. Okay, there's also B intersect C here. Okay, so you can see that there's A intersect B and there's B intersect C. Okay, so now do we put them together? We just put them in brackets, the sets we have identified, and put union. That is how to handle it when you have identified two sets and you see that this set is shaded and this other set is shaded. To put them together, you use union. Okay, what about this one? I think this is everything. I don't think I've got any. Okay, one more just in case. So what is this set? The only part that is not shaded is this. So what is this? This is the part that is not shaded is the intersect of the three sets. A intersect B intersect C. So it means this is A intersect B intersect C complement, because they've shaded everything outside the common region shared by the three sets. So this marks the end of this part of the topic. Watch out for the last part.